Siemens has built a global reputation on safety, quality, reliability, and support. The mission of FCC Inc. has always been to provide the safest, most reliable, best supported total boiler room control solution to burner boiler manufacturers and their representatives, as well as their end user customers throughout the markets we serve. Now, before we proceed, I would like to take a moment to mention these common standards that are related to the burner boiler industry. When using Siemens in your applications, be assured that all Siemens equipment will comply with the requirements of all of these standards and approvals. Common standards applied in North America include NFPA 85, CSD 1, CSAB 149.3. Common approvals for flame monitoring controls include ULCSA, ULFM, and SIL 3. Now this final one, not everyone may be familiar with. SIL is defined as a safety integrity level of equipment. And putting it simply, it's a measure of the performance that's required from a safety instrumented system, in this case the LNV, to maintain or achieve a safety state. You may recall how I mentioned Siemens has built a reputation on safety. Well, this ensures that the LNV will take the necessary measures to prevent a hazardous situation from developing. Additionally, a SIL rating is based on a scale of 1 to 4. The Siemens LNV system maintains a 3 rating. Now, the goal of this webinar is to educate the customer on the information that is required to quote a system and have no surprises when that equipment arrives. When we examine the control solutions and the options on these pieces of equipment, there are quite a few things one has to consider before a system can be quoted. For the burner boiler control, parallel position linkages control, ultra low NOx control, O2 trim control, VFD burner blower control, fuel safety control including valve proving, burner boiler HMI touchscreens, level control, and finally draft and economizer control. For a deaerator control, it's pump rotation, pump lead lag control, pump motor VFD control, and finally level pressure control. And finally, to tie all this equipment in together, the plant master management system. This would include the boiler lead lag control, system monitoring, trending logging, and remote communications via protocols. Now, with the DA and the plant master, these are topics that we will not be covering today. These have already been covered in great detail by my colleagues in previous webinars, and at the conclusion of this webinar, you'll be provided with a link to our YouTube channel to view these. Now, before we contemplate quoting a retrofit, I think it's important to look at a few examples of when it may be time to just upgrade the equipment entirely. Factors to consider when a retrofit may not be the best option. First, age of the equipment could be at a point that the components become very expensive or difficult to procure. 2, manufacturers no longer in business. Over the past 10 years, many of you have experienced this with certain manufacturers closing the doors and parts are no longer available. Poor efficiency and performance. This could be a combination of poor burner design, overfire equipment, or poor equipment selection for the application. New emission standards. Due to legislation, it has forced many manufacturers to improve the design of their equipment. Existing equipment does not meet these standards. And finally, high maintenance costs. This could be a combination of the age of the equipment, ability to procure parts, and the ability to maintain the equipment running. Now, with that out of the way, let's talk retrofits and what pertinent information we will need to provide a comprehensive quote. First, what equipment? Are these certain components on the burner, or is it a complete package we're looking for? Why is the customer requesting to have this done? Is it for better efficiency or improved turndown? Is it better NOx performance or better performance and repeatability or improved safety? Whenever the discussion of retrofit comes up, I always ask, what is the driving force behind the retrofit? What I have come to find out that instead of presenting the system take a moment and just listen to their frustrations. Once they're done vetting, ask their questions, and chances are the job will be yours. Finally, what is the goal? Is it improved efficiency and energy savings, improved safety and reliability, lower overall costs, or is it real-time availability of status and performance? Goals often depend on who the customer is and their role within the organization. What I have found over the years is that not every job that has been sold is driven by efficiency or savings. Yes, that may be an outcome, but if you are dealing with a production manager, his concern may be the reliability of the system. He may care more about the availability of real-time status and performance. So now, let's take a look at the components of the burner boiler. You have the parallel positioning system. In this case, we're showing the complete panel. You have the air damper assembly, gas valve assembly, oil valve assembly, the flue gas recirculation, O2 trim, VFD, the gas safety shutoff valves, the oil safety shutoff valves, the gas flow meter, level control system, draft control, and finally, Economizer. Now, during the remainder of this webinar, we'll examine each component on the burner and determine what information is required to size these properly. Now, before we proceed, one thing I'd like to point out, SCC panels undergo a thorough testing procedure prior to shipment. This includes software, wiring, and quality control. Now, all the panels are UL labeled. Panels are provided with complete electrical schematics. Panels are tested prior to shipment, and SCC maintains a record of all panels shipped. This is very beneficial, especially if you purchase a panel and say 5 years down the line something occurs and you need the drawings. We maintain a record of that job and we can easily access that and send it off to you. Next, considerations. Considerations include, what is the timing of the project? Is this something that needs to be completed in the next week or two, or during the next shutdown, which may be 2 months away? Do you have enough manpower? On the average, a panel can cut down installation time by 50% or more, depending on the complexity of the system. And finally, on the average, a panel will be approximately about 20% more versus loose parts. However, if you take manpower, drawings, installation time, and material costs into account, the overall cost is substantially less than purchasing the loose parts. Options to consider: LMV5 or LMV3. This will be dependent on the burner size and what features they're looking to have with their control system. Touchscreen or serial kit, expanded annunciator, and finally, additional I/O. This may include additional steam flow, water flow, or additional temperatures that they may want to record. Now, one of the first components is the air damper and FGR damper. Questions we need to answer is the diameter of the shaft. What is the length of the shaft that we're connecting to? What is the mounting location? What is the torque requirement? Is it an indoor or outdoor application? Standard or high temperature brackets and couplings? And finally, what is the size of the current FGR valve? Now, for an assembly, there are two components required, a coupling and a bracket. We will cover both and how to size it. First, we'll do the coupling. Now, features of the coupling: they allow for 3-degree angular misalignment. They allow for 63 thousandths of an inch parallel shaft misalignment. They accommodate English and metric sizes, 0 backlash, and finally, they're maintenance free. The flexible coupling design, in this case, minimizes the side loads on the actuator and the valve shafts due to minor misalignment, which in turn helps prevent actuator binding, improves control performance and reliability. Now, options. There's a CC or CD coupling. This coupling is used primarily with the SKM 45 or SKM 33, which is either LMB5 system or LMB3. And then you have a CF or CH coupling. This one is used with SKM48, which is part of the LMB5 system. Next, we have the brackets. Now, our brackets are not only designed to align the shafts of the actuator and the equipment, but also to ensure that it's a rigid design. So with our brackets, we get precise shaft alignment, rigid design, and there's also multiple options. You can either have a standard or a high temperature version. You could have a pillow block, weld mount, blank, or threaded studs. Now, one of the things that we need to do is size the bracket. In this example, we're going to assume that we're using an SKM48 with a pillow block bracket. So if you look at the dimensions on here, dimension A refers to the actuator shaft length. Since we're using SKM48, that dimension is 1.54 inches. Dimension B is the valve damper shaft length. We will assume it's 2 inches. Dimension C is for the thickness of the valve damper bracket. In this case, we're using a pillow block, so it's 0.135 inches. And finally, dimension D is a correction. Since we're using SKM48, that correction is 0. Now, I took the time to already do these calculations for you. Since we are using a CF or CH coupling, I calculated the minimum standoff length and the maximum standoff length using this equation, which is in our literature. And that length comes out on for the minimum 4.145 inches, and for the maximum 4.705 inches. Based on that information, these are the two brackets that will fit in this application. Now, if you use a shorter bracket, this could result in binding. If you use a longer bracket, chances are that actuator damper will not be coupled properly. Additionally, we do have specialty brackets for a wide range of air damper assemblies, oil pumps, and also oil valves. Now, you can go to our website via the links or contact your sales manager, and they can assist you in finding the right one for your application. Now, SCC also offers a complete FGR assembly. Therefore, if a customer chooses to replace an existing FGR valve, we have the capability to supply this. FGR assemblies are wafer-style valves. These assemblies are designed for both thermal expansion contraction. Therefore, it eliminates the possibility of the valve seizing up. Some of the features: it's a rigid and robust design, and the valve sizes are up to 24 inches. Options include multiple actuators, 450-degree Fahrenheit or 900-degree Fahrenheit rating, and a NEMA 4 rating. And in terms of literature, we are in the process of releasing the literature, so please check our website for updates. Now, we move on to gas flow control valve assembly. Questions that need to be answered. What is the burner high fire flow? What is the burner manifold pressure? What is the pipe size? And is it an indoor or outdoor application? Now, why a valve assembly? Well, I'll give you 3 reasons. 1, it's aluminum design and will never rust. 2, it's pre-assembled, tested, and inspected at the factory prior to shipment. Additionally, you don't have to worry about trying to fabricate brackets or couplings in the field. And finally, if you look at the cost of the complete assembly, you literally pay for the bracket, coupling, and actuator, and we throw in the valve for free. If you don't believe it, check it out for yourself. Secondly, a pinch shaft. It guarantees no slippage. Once again, a safety issue SCC has addressed. And finally, a modular design. The options include either a full, medium, or reduced port valve. And also we make these for natural gas, biogas, and propane. In terms of sizing, we do have a VKG sizing program, and we will go and do an example of this right now. Now, this program allows you to go in, and based on some information you input, it will select the valve size for you. So in our case, We're going to use the burner high fire flow at 21,000. Our manifold pressure, which is the downstream pressure of VKG valve, will be 20 inches. We're going to use the recommended 1-inch pressure drop, and we're going to use a recommended 60 degrees Fahrenheit for natural gas. So what this does now is it actually gave you 4 options. And at the bottom here, it gives you the option that is closest, I guess, to the target. In this case, it's a 2.5-inch MPT full port valve. Now, this is just a valve. If you want to build the entire assembly, you'll see a tab at the bottom that says a V8 part number builder. Please click on that. And what you do is, since we're going to do LMB5, you go in and select the SKM45. Remember, the SKM33 is for the LMB3 system, but you can do the same thing if you happen to use that system. Next, it's a MPT valve. It is full port. The size is not 2 inches, it's actually 2.5. And we're not going to choose NEMA 4, so we'll choose the standard NEMA 12. And what it does is it builds a part number for you. In this case, it's a VA 45.2-NF-250. And this program will actually be one of the handouts that you will have available to you. Now, O2 trim. This one is rather simple. You need to know the stack diameter. You have to ask yourself, what efficiency gain can be generated from the O2? And this is something you have to consider. Where is the burner boiler currently running at versus what is the potential where it could be running? And finally, what is the payback period? This is all dependent on the size of the burner, the average operating load, average operating time, and current fuel costs all play a large role in how quickly the customer can expect to recover the cost of the O2 trim system. Now, for sizing purposes, all one needs to know is the stack size. There are only 2 options offered for the collector in terms of size. Some of the features includes a zirconium dioxide sensor, a self-calibrating O2 sensor, and an easy to install collector. In terms of VFD, questions you need to answer is, what is the motor horsepower? What is the voltage? And is it TFC or ODP motor? And finally, is it normal or heavy duty? One thing to keep in mind here, if it is a normal duty motor, it may or may not be able to accept the VFD. That's something you will have to check with the manufacturer. Now, one thing I'd like to point out is all the drives that are purchased from SCC are pre-programmed at the factory prior to shipment. It's really nice in the sense that once you get the VFD, all you have to do is wire it up, install it, and it's done. All the drives are vector drives. With the VFD, you're allowed a fully characterized speed curve. You have noise abatement. You have additional safety in terms of actual motor speed, and additional safety in terms of motor rotation is verified. And finally, you get reduced power consumption. Options include a Yaskawa drive, or you can use the existing drive that you already have. However, please note, make sure it's a vector drive. Why a vector drive? Well, a vector drive provides a more accurate torque control of the motor. This enables much more accurate speed of the motor at lower speeds. More accuracy equals reliability and repeatability. Finally, when you do order a VFD, you will receive an email, which is a VFD application questionnaire. The whole purpose of this questionnaire is to ensure that the VFD you ordered matches the information that's input on here. The last thing we want to do is order a VFD, come to find out it's the wrong one, and then you have to order a new one. Next, we're going to cover the gas oil shutoff valves. Now, the questions we need to answer here are, what is the required gas flow at high fire? What is the inlet pressure, or gas pressure, sorry, to the train? What is the burner manifold pressure? Is it an indoor or outdoor application? Does it require an actuator heating kit? This would be primarily if the temperatures are sub-zero. And finally, are you looking for a complete train or just loose parts? Now, some of the features of the gas safety shutoff valves: it is a modular dual body valve and regulator, which reduces the potential for leaks. It offers you a visual indication on the actuator to see that your valve is open or closed and where it's positioned. It is a aluminum body and Buna N disc that does not corrode. And finally, the valve has an excellent safety track record. Options include NEMA 4 protection, and you also have the option for a pre-built gas train. Finally, sizing. You have the SSOV sizing program. We will cover the pre-built gas train SSOV sizing program in a bit, but first we're going to cover what the advantages of the Siemens gas train design are. So first, let's take a look at the traditional gas train that everyone is familiar with. In this gas train, you'll first notice that there is a total of 11 connections between the regulator and the high gas pressure switch. Each connection presents a potential leak point. Now, let's assume that we have a 500 horsepower boiler with 5-pound gas supply pressure. The majority of the pressure drop occurs at the regulator. If the burner requires 20 inches manifold pressure, the regulator will drop the pressures, say we'll drop it from 5 psi to 23 inches. This is set slightly higher to compensate for the pressure drop across the safety shutoff valves. Now, manufacturers will normally increase the size of the traditional safety shutoff valves to compensate for additional pressure drop through the SSOVs. Therefore, for this size boiler, gas train will probably be 3-inch based on these conditions. Now, let's take a look at the Siemens gas train design. First, you will notice there's only 2 connections, so the possibility of leakage is greatly reduced. Next, the regulator is the secondary safety shutoff valve, and the pressure drop occurs at this valve. Finally, the downstream sensing line before the firing rate valve maintains a pressure of 20 inches water column. Since we take the pressure drop of the second valve, we have the ability to reduce the size of the double gas valve to 1.5 inches. So the Siemens advantage allows us to maintain the same output, but with a smaller gas train. If you don't believe me, let's do an example. Now, the sizing program allows you to select options based on your application. It includes drop-down menus and allows you to select the available options. Once this section is completed, it will proceed to the next section, ensuring that all the information has been provided. So we'll go through an example. First thing it asks is which gas train, or will the gas train use a combination safety shutoff valve and pressure regulator? And we will select the combo SSOV with SKB 25. Choose the number of shutoff valves. We'll select 2. Is there a vent required? We're going to say no. Do we require a firing rate control valve? We're going to say no. If you know it's already selected the gas for you, if you are looking at a different type of gas, you could just go to the drop-down menu and select it. But for this purpose, we're going to use natural gas. Choose your units for your gas train supply pressure. In this case, it's PSIG, and we're going to choose 5 pounds. What is the burner manifold pressure, or the units for it? Inches water column, and we're going to select 20. Next, what is the desired turn down? Your options are 10-to-1, 15-to-1, 30-to-1, or greater than 30-to-1. For our application, we will choose 10-to-1. Choose the method to specify the gas train capacity. We're going to go based on gas flow, and we're going to choose 21,000. What switches are desired on the upstream safety shutoff valve or actuator? We'll do the POC. And what switches are desired on the downstream safety shutoff actuator? We'll do POC as well. Next, select the desired inlet pipe size to the safety shutoff valve. We'll select 2-inch. Please select low pressure switch option. We'll do a manual reset. High gas pressure switch. We'll do manual reset. And then finally, is a valve proving switch required? And we're going to select yes. Once all that is done, you could hit or go onto this generate parts list and click on it. And what it will do is it will select all the parts that are required for this gas stream. As you will notice, for this size boiler, based on the conditions we put in, it did select an 1.5 inch gas valve body. This program will also be included in your handouts. Next, we're going to cover a pre-built gas stream. Now, I took the liberty of filling out all the information. Very similar format as the other program, where you do go and select what type of gas you have, what the flow is, your inlet gas pressure, your pipe sizes. Some additional questions this will have is if you want a Y strainer or inlet drip leg. You go through, fill out all the information, and you can use the sizing program to determine what type of information you have to input in here. Some additional questions it will ask is whether or not you want pressure gauges and also if pre-wiring is needed. Once you fill out this information, send it back to either your account manager or customer service. And within a day or two, you will be provided with a complete list or a bill of material, as well as engineered drawings like you see right here. Next, we proceed to the oil valve assembly. And there's certain questions we have to answer here. One, what is the burner gallons per hour flow? What is the oil pressure at the nozzle? What is the pressure drop? What is the pipe size? Is it an indoor or outdoor application? And finally, what is the current valve? Now, just like the gas valve assembly, Siemens offers a complete assembly for the Hawk oil valve. Some of the features include it's pre-assembled, it has precise shaft alignment, and it is available for the S, AS, B, F, G, and H valves. Options include you could purchase either the full assembly or a bracket retrofit kit, but it's very important to let us know which valve you currently have on there, because depending on which valve it is, they do have different brackets. In terms of sizing, you can use the Hawk capacity oil tables. Now, gas flow meter. Questions that need to be answered is, what is the max flow that is required? What is the current line size? What type of gas is it? What is the available straight run pipe? Now, straight run pipe is very important because with these meters, they normally require 15 pipe diameters upstream and 10 pipe diameters downstream. Now, features include, it does compensate for gas temperature and pressure. It is an insertion meter. It provides you with instantaneous flow, and it does have 4 to 20 milliamp or pulse output. Options include, it's an insertion type meter. They do offer a flow straightening option as well. You can get it in either a 9 or 12-inch probe, and we also do offer this as part of a commissioning kit. In terms of sizing, in the links below, you could either go to table 1 or table 2, and based on the line size, select the appropriate flow meter for your application. Boiler level control. Things that we need to answer. What is the boiler horsepower? What is the feed water pressure at the valve? And finally, what is the operating pressure? Now, for the boiler level control, some of the features include it is a full PID control. It is scalable. The DP transducer offers you the ability for blind setting. What this means is you do not have to empty and fill the boiler to set up your DP transducer. It can be done based on measuring the height of the reference leg. It is a class 4 shutoff valve, and it does offer 0.065% accuracy of full scale. Options include, if it's less than the 50-pound differential, you can use the 599 series valve. If it's greater than the 50-pound differential, we do have a third-party partner that we work with that has valves that are good up that have valves that are good up to 150-pound differential. They offer two types of actuators, either 230-inch pound or a 600-inch pound actuator. The range on the DP transducers is either 0 to 100 inches or 0 to 250 inches. And you either have the ability for Modbus or no Modbus capability on the RWF. In terms of sizing, we do have a feed water builder program, and we're going to do an example right now. Now for a feed water builder program, I've already taken the time to fill out the information to save on time. So very similar to the other sizing programs we did. With this one, you select whether you have a boiler or DA, how many systems you're looking at. Choose the DP transducer range, usually 100 inches suffices. Whether you want a display or no display on the DP transducer, the only difference here is what type of cover they have on there. If you choose no display, it's a solid metal cover. If you choose a display, it's a metal cover with a glass insert. What type of connection to the transducer? We chose three-way manifold. It's very nice because it allows you to isolate the DP transducer from the boiler without having to shut the boiler down. Whether you want Modbus or no Modbus, in our case we want Modbus. Next, you input what size is the boiler or the output, in this case 500 horsepower. What is the maximum operating pressure? In our example, we're going to use 100 psi. And what is the feed water pressure of the valve? We're going to use 135 psi. And finally, the temperature of 235. So what this program does, it did select a valve for us. If you look down here, it selected a 3/4 inch valve. Now, you do have two options. The first option is evaluation of the selected valve at other differential pressures. What this means is currently our differential pressure is 35 pounds. Now, say we don't have 35 pounds. Say we only have 25 pounds because the inlet pressure to the feed water valve is only 125. Well, we'll put 25 in here. And what it will do is it will check to see if we have only a 25-pound differential, if the 3/4 inch valve will be able to meet the demand. The second option is, based on the above conditions, instead of a 3/4 inch, say we want to use a 1 inch valve. Well, we have to look up the CV value. Well, they provide a nice chart here for you, and you see that a 1 inch valve has a CV of 10. So in that case, we input in 10 in here. Next, we go to the tab at the bottom, which says optional valve evaluation. And what it will do is it will provide you with three charts. The first chart is based on the conditions we put in and how it selected a 3/4 inch valve. And you'll see that the minute max flow for that valve is 1.91 gallons per minute up to 38.24. And it falls within the range for this application. The second chart is based on the 25-pound differential for a 3/4 inch. In this case, the 3/4 inch valve will be too small to meet the demand. And finally, the third chart allows us to, we selected a 1 inch valve versus a 3/4 inch based on the initial conditions. And it tells us, yes, this valve will be okay as well. So it gives you multiple options in terms of how you want to go about sizing it. Finally, if you click on the report tab at the bottom here, it'll give you an entire list of all the components that you need for your level control system. Next, we have the boiler draft and economizer control. Questions that we have to address here is the boiler stack greater than 50 feet? And do two or more boilers share a common stack? Now, the features of this system are, it has a dynamic graphical display. Now, the dynamic graphical display for stack draft pressures provides operators with a visual aid for operational monitoring. It also has Modbus communication to the LNV, which helps minimize the amount of field wiring. It has a continuous stack damper monitoring, and it is UL 508 and UL 378 listed. Options include 140, 310, and 400 inch-pound actuators. And you could also get this as a standalone system or part of a touchscreen control package. You all have received a TS configurator. Within the TS configurator, if you are looking to configure a panel either for the LNV3 or 5, one of the options is whether or not you want a draft control system, and that's where you would put the information in. Finally, additional instrumentation. Siemens does offer additional instrumentation, especially in a boiler room. There's instruments all around us. We do offer vortex flow meters. These are primarily used for water and steam. Electromagnetic flow meters, which are used for water. And finally, differential pressure transmitters, which we use for level or flow. But when you're dealing with flow, you do require an orifice plate. Now, the information that we do require for these is what is the minimum and maximum flow? What is the medium? Meaning, is it water, steam? What is the temperature? What is the pressure? And what is the line size? Options include remote heads, high temperature applications, as well as high pressure applications. Now, one thing to note, pricing usually takes 3 to 5 business days. These are all specialty instruments in the sense they are not kept on the shelf. So we do send the information out and we get pricing from one of our other divisions. When you do order a instrument, the delivery time is usually 4 to 8 weeks. So just be aware of that, please. Finally, in summary, Siemens retrofit options are limitless. Siemens does have a solution for about 95% of retrofit. If it doesn't, chances are you need to upgrade the equipment. Measure or calculate twice, order once. Incorrect sizing will lead to unnecessary expense. Correct sizing optimizes control and cost. Pictures are great, but pictures and documentation is better. And finally, providing the critical information will result in no surprises. Here I offered you some resources, so when you download this presentation, you'll be able to go to either our website or our YouTube channel, and also there's a link to news and events, and this is normally where we post any new products that come out or any new news about any of our products or things we may have released.